Hi students, Joe Silverman again. Going to try a little bit of Camtasia for lecture 5 on elasticities. Once we get through lecture 5, or once you get through lecture 5, I guess would be a better way of putting it, you'll be ready for the exam. Now, let me mention something about elasticities before we get started. It's a concept I think that's very important in economics, especially if you're ever in charge of actually pricing a product, which you may be. And there's a couple different ways. There's first off a couple different elasticities that we're going to talk about, and there's two different ways of calculating the price elasticity of demand, and the one that I want you to focus on is using the midpoint formula. But we'll get into that a little bit more as this lecture progresses. So an elasticity can refer to either supply or demand, generally speaking, and at least for this lecture, we're going to focus on a thing called the price elasticity of demand. Why is this such an important concept in economics? Because an elasticity basically provides us with a number that tells us how sensitive consumers or producers are to a change in price. Also, something to note is that the formula for calculating the price elasticity of demand looks an awful lot like the slope formula. And one of the things I've seen students do over the years, which I hope you guys don't do, is set up the problem wrong, do all the calculations correctly, and then get the wrong answer. So we'll discuss that a little bit more as this lecture progresses. But please be sure that you do not confuse the price elasticity of demand, or supply for that matter, with the slope of a line. All right. So what is the generic formula for calculating the price elasticity of demand? It's the percentage change in quantity demanded divided by the percentage change of the price. What it what it does is it provides us with a number that tells us how sensitive consumers are to changes in price. Now we know that when the price goes up, quantity demanded goes down. So this number, percentage change in quantity demanded divided by percentage change in price, whatever that happens to be, is going to be a negative number. In order to get rid of the negative sign, in order to just focus on the number itself, what we're going to do is we're going to take the absolute value of whatever it is, whatever the final number is that we calculated, and then that way we can determine whether or not people are price sensitive or maybe not that price sensitive at all. Does that make sense? So we're going to have, if the price were to go up, we'd expect quantity demanded to go down. We could also calculate it the other way. With the price going down, quantity demanded would go up. That's just the first law of demand. We know that whenever we're talking about the price elasticity of demand, we're going to get a negative number, so we take the absolute value of that to get us out of that land of negative numbers and just focus on the number itself. All right, now the formula that I just gave you is the general formula for the price elasticity of demand. I want you folks to use the midpoint formula. Now, why do I want you to use the midpoint formula? Because it's more precise, at least there in the midpoint. That's one reason. Another reason is when you calculate, if you were to calculate the price elasticity of demand and you did not use the midpoint formula, your starting and ending points would give you two different numbers. If you use the midpoint formula, it doesn't matter if you start at Q2 and go to Q1 or start at Q1 and go to Q2, you're going to wind up getting the same number. Okay, now let's just say we went through some calculation and our final number winds up being, for our price elasticity demand, winds up being the absolute value of negative 0.10. This is all fine and dandy if you're quantitatively oriented, but if you were, let's say, working for somebody and your job was to do these calculations and then explain to that person what it means, it would be nice to be able to take this number and put it into words. So what does a price elasticity of demand of 0.10 mean? By the way, why am I referring to this as 0.10? Because we're taking the absolute value of this negative number. The meaning of a price elasticity of demand of 0.10 means that a 1% increase in price would lead to a 0.1% decrease in quantity demanded. So, in generally speaking, if I were doing a lecture class, what I would do is I'd ask students if that was what you calculated for your product, what should you do? Should you lower the price? Should you raise the price? Should you leave it the same? I'm going to cut to the chase because we don't really have the ability to go back and forth on this. If you calculated something like this, then you should raise the price. Why is that? Because your customers are not price sensitive. A 1% increase in the price is only going to lead to a 0.1% decrease in quantity demanded. You are lucky to have one of those products where people will, at least for a little while anyway, continue buying that product even though you've just raised the price. All right, so let's take a look at an example using some real numbers. So again, we start off with our general formula for the price elasticity of demand. Now what we're going to do is we're going to add some value. So the first thing I want you to note is we have percentage change in quantity demanded in the numerator. That's actually what we get off of our x-axis. Quantity in economics is placed on the x-axis. And then we have the percentage change in price on the y-axis. So we're taking what we have on the y-axis and putting it in the denominator, taking what we have on the x-axis and putting it into the numerator. All right, now if we're going to use the midpoint formula, I want to go through the graphical representation first. What we're saying is imagine that we have 2 points. Imagine we've identified point A and point B, and the coordinates for point A are 10,000 and 30, and the coordinates for point B are 20,000 and 25. What we're saying is there's some point, we're going to call this M, that is halfway between A and B, and at that point, exactly at that point at M, we're going to calculate the price elasticity of demand. So what we're going to do is set up a complex fraction. I'm sure all of you remember how to do that. Intermediate algebra is a requirement in this class. We aren't necessarily going to use algebra here, but if you got to intermediate algebra, then you know how to set up a complex fraction. All right, so what you're going to do is you're going to start off with your quantities, putting them in the numerator in a complex fraction, and then dividing that by the prices, which we put in the denominator. So it doesn't matter whether you start at A and go to B or start at B and go to A. You will get the same number if you use the midpoint formula. So let's just say we start over here at B, so the coordinates are 20,000 and 25. So I'm going to put 20,000 in the numerator portion of the numerator, and this 25 over here is going to go into the numerator portion of the denominator. So what we're going to do is we're going to subtract one quantity from the other. So 20,000 minus 10,000, that's how we get that. And then we're going to look for the value that's halfway between 20,000 and 10,000. That's 15,000. So all I'm doing over here is going through all the steps. So 20,000 plus 10,000 divided by 2 is equal to 15,000. And we're going to do the same thing for the prices. So if our coordinate at B, if our x coordinate was 20,000, our y coordinate is 25. What are we going to subtract from that? We're going to subtract our other y coordinate, which is 30. So 25 minus 30, that's negative 5. And then what are we going to do? We're going to find the point that's halfway between 25 and 30. That's 27.5. And so now all I've done here is simplify. So what do we have? We have 10,000 divided by 15,000. And we're going to divide that. That's in the numerator portion of our complex fraction. And then we're going to divide that by by negative 5 divided by 27.5. All right, so what did I do here? Well, let's see. So this is what we've got set up. I guess I rewrote this. And then the way that we go about solving a complex fraction is, remember, we have to invert. We have to take the reciprocal of one side, which is what I did over here. I just simplified this. 10,000 divided by 15,000 is 2/3. And then when I got to this step, all we're doing is, instead of trying to divide 2/3 by negative 5 divided by 27.5, I just went through this additional step. My suggestion, by the way, even if you have a calculator that you can plug all these numbers into, is to do as much of this math as you can kind of by hand. And when you get to the final step, plug those numbers into your calculator. You're less likely to make a mistake. In other words, if all you're doing is multiplying 2/3 by 27.5 divided by negative 5, you're much more likely to get the right answer. So in this particular instance, it says that our price elasticity of demand is equal to the absolute value of negative 3.7. Again, we're going to strip away the negative sign from there, and basically we have a price elasticity of demand of 3.7. What does that mean? A 1% increase in the price is going to lead to a 3.7% decrease in the quantity demanded. So if you had this kind of product, in other words, if you were making this product, your customers, whoever's buying this, are very price sensitive. A tiny change in the price is going to lead to a big decrease in quantity demanded. All right, so what I'm going to do is I'm going to end this video here, and then I'm going to talk about the significance, the importance of the price elasticity of demand with respect to a thing called total revenue. Thanks a lot, folks, and I will be posting the other one shortly.